All right, so today we're talking about SDN. We branded this as DNA, SDA, and ACI. But generally speaking, we're just talking about SDN and what SDN can do for you. Is it real? Is it fake? Like Mike said, I think it's real. I mean, we have working examples. It's very real. And the question is this undermarketed? In other words, are they telling lies? In some cases, they're telling, I hope this will work one day. But for the most part, the expectations are being met. We are several versions into a lot of the software now. Were you guys early adopters? How early?
Well, for ACI, 3 years ago.
Okay, so you were fairly early adopters. So 3 years ago, the software had some different issues, but now it's much more mature, and we believe it's kind of ready for the enterprise, and it's ready to go it's ready to be submitted to the wild. So specific around SDN, what is SDN and what's it supposed to do for you? I like to make a point that people often, anytime you take software-defined something, they believe hardware doesn't matter, right? The instinct is, oh, it's all software. It doesn't matter. We can just put it on anything, do anything we want, whenever we want. I don't subscribe to that theory, right? I'm of the theory that software has always driven our endpoints, our switches, our routers, right? Those things did not have software on them before. They still have software on them today. Now the software is changing. And what it's doing is becoming kind of easier to work with and easier to adapt, right? In some cases, SDN is just a beautiful GUI. It's a beautiful facelift. But it's about opening up APIs. And it's about kind of building this interoperable platform that now makes things easier for you to do, like VLAN automation, switch provisioning, right? Zero-touch components, integration from security. I thought of stakes already. Integration between security, right, and your backup products. Understanding that different products have different needs and different applications have different requirements. And if you allow the application to dictate the requirement and not you as a network administrator, you can probably save a lot of time and make your network more intelligent. So that's really what SDN is. We see it on right, I mean, software-defined, the entire AWS and Azure architecture is all SDN. But it is running on hardware. And it's still sending VLAN commands to those hardware. It's still doing something to segment your data. So I don't want people to get kind of locked into the fact that maybe this is just non-existent technology or it's kind of vaporware. It's true, it's real, and in some cases, it's hardware dependent. For both cases today, it is hardware dependent. So here are the takeaways. This is what I want you guys to leave with today, and we'll cover them at the end again. But if you walk out of here, these 4 things are the most important. Number 1, if you're a consumer of Cisco Catalyst products, not Meraki, Catalyst products, all right? So if you're a consumer of Catalyst switches, or now all the access points are now moving into Catalyst access points. If you are a consumer of those products, within the next 5 years or within your next refresh cycle, you'll be running DNA or SDA. All right, now DNA and SDA are married, and I'll discuss that in a little bit. Number 2, and this is conceptually the most difficult thing to get today, is layer 2 is dead. All right, so what you know today as traditional layer 2 in the network is dying quickly, we hope. In fact, when these products come in, you will no longer see that layer 2 in a traditional manner. All right. Number 3, all workloads are created equal as far as ACI is concerned. So it used to be that only if you had a very, very large infrastructure with lots of nodes and lots of devices, ACI was a fit. Really, it's workload dependent. If you have a requirement for it, ACI is a fit. If you're cloud, ACI is a fit. And I'll explain that in a little bit. Last but not least, ACI for cloud is the game changer for cloud. People who are looking for hybrid networking in the cloud want a little more control. Right? The ACI Anywhere option is going to enable that. And we'll cover that at the very end today. So those are our takeaways. Out of the gate, DNA, SDA, and ACI, what are they? Right? Mike, you want to?
Oh, yeah.
I got it. I got this one. All right? So SDA is software-defined access. This is a Cisco-branded product. All right? They are pushing that out there. This is for the campus. ACI, that's the data center side of a very similar technology. There are common principles between these guys, and they're listed on the left-hand side. The common principles of both SDA and ACI are location-based routing. They introduce the idea that we can know where you are, and we can extend layer 2 to anywhere and not really care. We have a registry of that. We've got a point that tells us where all these devices are located, and we don't care about where their VLAN is, or we don't care about their layer 2 address is. Other common principle, extend layer 2 over layer 3. These two together are what dictate that layer 2 is dead. Security and microsegmentation. This is a common driver between all these products, right? They want the security. They want to be able to microsegment all of their devices or all of their servers into one group, right? It used to be, previously, if you wanted to segment something, you built a VLAN, you put it behind a firewall, you put a DMZ behind it, you built all these components and built all this configuration to segment out these end users. Now, while that is, I would say that's easier in the data center, that is brutal in the end user environment. QoS priority. A lot of this stuff, people kind of forget that some of these applications, they require different levels of QoS. And those different levels of QoS can exist depending on where they are. It's the same with end users. If you need the backup application to have QoS between the backup hours, let's call it between midnight and 6 a.m., well, then you should have a policy for backup. But if you don't want that policy active during those times, well, then you should be able to remove that policy or change that policy. That's part of SDA and efficiency, being able to change dynamically with the flow of the application. So everything gets the priority it needs, wherever it is, with the security it needs. Last but not least, they're API enabled and they're fabric based. All right, so API enabled, that's an easy one, right? Interop with other applications, you can have people write code to it. Just because it says API enabled doesn't mean you have to have developers to take advantage of it. It means you're relying on other partners to take advantage of those APIs to have those integrations. Fabric based, that's a little bit different. So most people, when we refer to fabric in let's call it 5 years ago, it was generally a fiber-based fabric. It was just a unique word for that. In this world, fabric-based means every device operates as one. They all have the same common thought. They all have the same common plan. Basically, in some cases, they all have the same route tables, the same ACLs, and that's what fabric-based means. It means you're deploying a fabric. In a lot of cases, whether you're in or out of that fabric makes a difference on whether you get the policy. Differentiators, campus versus data center. Very important. SDA, campus. ACI, data center. All right, so when we talk about SDA versus ACI, that is campus versus data center. Two completely different products with the same common principles. So in terms of campus versus data center, we're talking about users and devices versus servers and applications. Those are the buckets we're going to put them in for this discussion. And last but not least, definitely the hardware is much different, and the management plane is significantly different. Right? Which brings us to our next slide. DNA versus APIC. It's actually DNA-C, right? DNA controller. But DNA is married and tied to SDA, whereas APIC is tied to ACI. Right? APIC is Application Policy Infrastructure Controller. DNA is Digital Network Architecture Controller. Right? Currently, DNA is 100% for what they call the enterprise networking side, not the data center. So DNA today manages routers, switches, access points. There are some other things as well, some software components, but for the most part, anything your end users connect to gain access, that's what DNA is going to manage. ACI lives in your data center. It's going to manage your data center switches, UCS if you've got UCS and the management's still being built out there, or integration with VMware, things like that. So let's tackle it one at a time. So we're going to tackle DNA plus SDA first. All right? The reason why I'm going on the SDA side, again, it's a campus kind of vision, is that I think it's easier to understand devices for people. Hey, how do I segment an iPhone from a PC? Rather than let's talk about layer 7 applications. So we'll start here, and then we'll get ourselves down to ACI as it goes. So what is DNA and what it's supposed to do for you? So the first thing I like to say is DNA is a box. Anyone seen Silicon Valley? Right? I'm selling a box, right? I want to put it in a box. It is a box. It is a hardware device that you are buying. All right, you are taking that hardware, you're plugging it into your rack, you are plugging cables into it. It is not vaporware, it's not some cloud application today, but it is a box you are buying. That box happens to run Linux, it happens to run Docker's containers, and they orchestrate it through Kubernetes, blah blah blah, all that fun stuff. But at the end of the day, you are buying a hardware box, and that is a management plane. All right, what that does for you is it enables automation, zero-touch provisioning, it's policy-driven, and it's a future replacement for Prime. Mike said something, I don't remember exactly what he said, but he kind of said we're always true to the customer. Cisco's not here today. They may show up, but it's a good time to say this. They are selling DNA as a replacement for Prime today. We would like you to take out Prime and put DNA in. They told us that on the phone yesterday. They reiterated again several times. We got this great product. The feature parity is there. We want you to have all your customers run DNA. I'm here to tell you, don't do that. Do not replace DNA for Prime. I think Prime is just okay as a product. Anyone actually operate Prime? Right? Do you guys like Prime? Yeah, ish? It's like, yeah, okay, right? Cisco has this belief that you love Prime and you're afraid to leave Prime to go to DNA. We don't hold that belief. We think that Prime is just okay and DNA hopefully is better. Now, the truth is you run DNA as well? All right, so DNA is better. I am here to tell you DNA is definitely better than Prime. There is not feature parity yet on reports, especially around wireless. So if you're a Prime user, don't rush to go to DNA. If you are not a Prime user, then hey, let's go. And I'll tell you why. All right. DNA is not Meraki. I want to underscore that so many times so people don't leave here thinking all my Meraki gear is going to be managed by DNA. That being said, it is roadmapped. Right? It will be roadmapped. Meraki is also not on the roadmap just yet for SDA. So I want to make sure if you've got Meraki today, you understand I'm not talking about Meraki products. It's also not Logic Monitor or SolarWinds replacement. I also believe that Cisco would have you believe that you can manage your entire architecture with DNA, and that's not true. There is some third-party device support, but it's very limited. Now, what they are doing with DNA, which should kind of blow your mind and make things better, is they are delivering a ton of AI data into DNA starting within 3 to 4 months. In fact, they're going to have big announcements on it at Cisco Live. They're now starting to basically aggregate all the telemetry available and all their installs are doing to start troubleshooting and giving you predictive data into your environment with DNA. So it is cool and it is coming. That's one of the limitations, by the way, and why they can't run it virtual today. Why do we have to sell it in a box? There is 2 other models that they're considering. One model is just a straight virtual machine. Another model is a cloud service. The reason why they are not deploying it as a virtual machine yet is because they've got new modules coming that will take the entire 46 cores and basically crunch data all day long. This is what DNA is. First, much prettier than Prime, right? I don't want to spend too much time on DNA because it's not what we're here to talk about. We're really here to talk about microsegmentation and what SDA can do. But this is essentially DNA. It looks like it's taken right out of the Meraki portal. Very pretty, very clean, right? Very overall network health centric. These are your scalable groups, which are some kind of things we're going to talk to you about. How do you actually group and organize a network? And this is what the fabric looks like, and it's presented to you in DNA. So if you have a DNA implementation, you're connected to Fabric, you get this pretty view of your Fabric, which is a unified view. It's your core, right? It's your edge, and it's your APs, along with your assignments. One thing that DNA is very good at is integrating with ICE. Anyone run identity services? You guys run ICE? Obviously, you run it independent of DNA. Who else runs it? You guys run it as well? So one thing that DNA is excellent at is integrating with ICE. So today, ICE can be a bear, right? Are you guys doing posturing or just profiling? Profiling at least?
No, we're not doing any of that. There's a project.
Perfect. You are going to love this. Speak to you then. How about you? Profiling, posturing? You're doing posturing as well? Well, 802.1x is the basics. If you're doing posturing, that's next level stuff. So posturing right now, I think, is probably 1% of our customers. ICE can be a bear. It can be very difficult to work with all your switch stack, all of your wireless stack, and ICE and make this all work and operate properly, right? So if you have an 802.1x, right, you guys running 802.1x at least with it? All right, so if you've got an 802.1x project on the table, these guys, Mike, those guys. If you've got an 802.1x project in the future, the next 20 minutes, pay attention. You're going to like it, all right? So back to SDA. SDA is basically SDA Access. This is a description right off of Cisco. SDA Access automates user and device policy for any application across a wireless and wired network via a single network fabric. And SDA Access is a transformational shift. That's marketing. It allows IT to set network access in minutes for any user, device, or application without compromising on security. All right, now that last part is true. The why, security, 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 performance, availability, identity, flexibility, and my favorite actual SDA customer testimonial, because I'm lazy. This is absolutely a true story. I asked the customer, why are you doing this? He said, I'm lazy. I said, perfect. I wish more of you were lazy. The truth of the matter is, after we're done, I hope you can appreciate that comment, because his laziness is his efficiency is what it is. So security, performance, availability, they go without saying. You don't have to talk about it, right? Everyone wants those things. I'm explaining how you get those while layer 2 is dead. Identity, flexibility. For me, that's the extension of layer 2 over layer 3 and the integration with ICE. So today, you're operating with identity. You guys have it as shelfware, right? Others who don't have it. Today, I think your CEO believes you know what goes on in your network, and your CEO says, oh, you know when that user's plugged in. You probably know everything that goes on here. And the reality is you guys know you know about this much, all right? These solutions give you almost the full picture, right? This is why we're here. So concepts, right? And this can be really deep stuff. So I'm going to stay as high level as I can. I'm going to make a lot of comments about SGTs and TrustSec and VXLAN. If I lose you, I apologize. But we can definitely come to your office and go into to greater detail. But these are the common principles, right? The concepts. Scalable groups, scalable group tags, ACLs, TrustSec, VXLAN, Lisp or location-based routing, identity services, 802.1x, wired plus wireless. These are all the concepts that are neatly stitched in a big box for SDA. There's more, right? There's other concepts that we haven't even got to yet, right? There's BFD. But I think in order to understand what kind of goes into this fabric, you don't need to know all this. That's the best part of all this. DNA is going to deploy the entire underlay fabric for you. What does that mean? That means you're going to take a switch out of a box. You're going to plug it into your core. You're going to tell DNA, I have a brand new switch. I want to provision for end user access, and it's plugged into these 2 ports. Go. Right? You're going to walk away. You're going to come back 3 minutes later. You're going to have a beautifully provisioned switch. Now, you all doubt me. I know you do. Right? You're like, really? Is it clean? Does it look like an ASDM got to it? That's what everyone's thinking right now. Because we've all used an ASDM tool, pushed an ACL to it, and saw like firewall underscore rule 1, firewall, and it just makes you sick to your stomach, right? It is clean as a whistle. I'm telling you from an absolute, that's my thing about working with Cisco, is you walk in, you can see, you do show run on any switch, and you can be like, oh, that was done by a hack. All right, that was done by somebody who knows what they're doing. I promise, you take a look at this, you're going to go, holy crap, I wish I knew how to do that. All right? The underlay deployment alone, right? First of all, it's all layer 3, so I think I cover that next. Right? It's all layer 3, right? Deploying BFD, deploying ISIS as a routing protocol, or ISIS, but we don't want to talk about that. Right? So I'll go into it. This is your current layer 2 design in your network, at least in some capacity. Some of you may have full routed access, but in some case, you have a switch that is a core, and it's got layer 2 access to the switches beneath it, and you now traverse VLANs across the entire environment. Right? That is, let's call it 95% of our customers. Very few of our customers are full routed access throughout the whole environment. And why are they not routed access? Because they know it breaks things. It's difficult. They need users in the same segment. They need mobility. Right? So they default to this. Right? Layer 2, port channels for redundancy across the board. Right? So what does port channels give you? I've given you one as redundancy. What's the second one? Aggregation. Link aggregation, more bandwidth. Right? So if I tell you we're going layer 3 everywhere, what do you think you're losing? Aggregation? Right? Redundancy? Maybe. How about convergence time? Convergence will kill you, right? So layer 2 converges a lot faster than layer 3. We all know that, right? So is anyone actually implementing BFD or know what BFD does? Extra credit for anybody in the room. It's not a routing protocol. It's a layer 2 protocol. It's bidirectional forward detection, right? It's like a UDLD on fiber, okay? It basically tells you, do we have one-way traffic or do I have somebody on the other end? So what BFD does, you integrate it into the routing protocol. So every routing protocol basically says, hey, is this BFD aware? Is my peer BFD aware? What that means is now, if I've got 2 layer 3 links to you and I lose connection to you, not an up-down interface, but actual BFD, if BFD fails, right, I pull that route from the routing table instantly. So now I have the same level of convergence as I've had with layer 2. And that is super important, because that's what you're giving up when you go this direction. You're saying all those benefits I got from port channels, I'm now willing to just throw away. Right? The second part of that is, anyone know what the hash is for a port channel? What are the 3 members of a hash for a port channel? How does it make a decision on routing or on switching? Anyone want to guess? Do you know? All right, I'll give somebody else. Anybody else? Right? So it can be IP based, but it's source. It's MAC, right? It's source MAC, destination MAC, IP. All right? That is the decision on layer 2. If we introduce ECMP, which is equal cost multipathing, this is how we get around in an all layer 3 world. It's now 5 tuples. I get my 5 tuple flow. Source, destination MAC address, source, destination port, protocol type, TCP UDP. So I'm actually giving you better throughput in my mind, or actually a better algorithm to distribute across your links. And you can have as many links as you want. You can have 2, 3, 4, 5, 6, as many as you want. There's no do this in 2s or do this in 4s. It's just pure ECMP. This is not rocket science. You basically do it. The other thing that's massive enablement in all these products is VXLAN. VXLAN is basically encapsulation of a layer 2 packet in a layer 3 packet. All right? But it's not outer intertag. It's not Q and Q. If you're familiar with Q and Q, that's one VLAN with another outer tag. This is actually basically a VLAN packet encapsulated in a layer 3 routable packet, which has VXLAN information, right, or location-based information. All right, so that's the first concept. Now, does everyone get why I said layer 2 is dead? Is layer 2 alive? It's totally dead. It's completely dead. It's totally dead. That means, and ISIS killed it. Yep. That was Mike. See, who's the guy? Who's the guy who has the same Same mouth? That's Mike. That's Mike. Now, so it is funny because ISIS, Lisp, right, BFD, all these technologies, these are old technologies. These are not new. You could have done this for years. I mean, literally, Lisp is like a 15-year-old technology developed by Cisco. It's location aware. What it means is every time you plug in the network, it knows where you are, not just that you're in this subnet or in this segment, right? So I said layer 2 is dead. I think VLANs are dead too. There's really no, your VLAN assignment or what VLAN person's on, that's not existent anymore. The only thing that you actually kept in this is IP. And you don't really even need that. You don't really need to know that either, right? The only thing you're going to use is large-scale IPs in this stuff going forward. So where it used to be, hey, I have a VLAN, it's voice, I'm going to assign that VLAN, whatever, 192.168.10.0, and I'm going to assign my data VLAN 192.168.20.0 in that building. But in another building, I got to now go 40 and 60. In this building, I got to go 70 and 80, right? You start building this crazy IP scheme. In SDA, I want every single phone in my entire organization to be 192.168.0.0. That's it. Doesn't matter. Build your networks as large as you can. In the design guide, they say, go crazy. I mean, don't go /8, but a /16 all away. You go nuts, all right? It doesn't matter where they are, what building they're living in if you're on a campus, even if you're geographically separate, right? What you care about now is you've got all these people grouped in an IP group. And it gets even more interesting. The IP subnet is not relational to their scalable group. You can have different people in different groups with the same IP subnet. You can have, I want all my users across the board, wire to wireless, to be 192.168.0, or 10.0, whatever that is, across the entire geography. But now, within that group, I want accounting to be part of an SGT. I want, finance to be part of an SGT. I guess finance and accounting is the same. Operations, right? I want manufacturing. All these guys have their own different groups, right? And that's what SGTs are, so scalable group tags. What that means is, on the ingress of communication from that endpoint, from that device, right? VXLAN wraps a header around it. SGT wraps a header around it. What do you get? You get now layer 2 has been encapsulated in layer 3, right? And now layer 3 has an additional SGT tag on it. That SGT tag determines its security policy. All the security policies are now built with SGTs. They're not built with IP addresses anymore. We don't care about that, all right? All of your SGTs, they live in the fabric. They can extend outside of the fabric, and that's where SDN comes into play. Right now, Palo Alto, Checkpoint, Cisco, obviously, for firewalls, they all honor SGTs. So if you want to build a scalable group in Active Directory, I want to build finance, all right? I want to put Jason in the finance department. I want to put Mike in the jester department, the joke department, right? I never want the jester to have access to finance, all right? And I want to make sure when Mike gets internet access, we keep him away from terrible sites and let Jason go crazy. Or vice versa, actually, right? Let's lock Jason down, right? That same policy, I drop one guy in Active Directory. You as a network guy, do nothing. Your policy is already set. Your hands are off. That person in Active Directory, now they get their VLAN assignment. Right, VLANs are dead. Now they get their SGT assignment. They get their IP assignment. They get everything they need because you've done that for them, right? Now these integration components are very important. It's SDA plus ICE, right, plus your partner device, whatever that is. If you're Palo Alto, if you're Cisco, or if you're Checkpoint, right? And it's not just those 3 vendors, but it's anybody, right, who follows the SGT component. So VXLAN is IETF standard. SGT will be an IETF standard. Cisco, despite all their, people kind of beat them up for a lot of things, what they do very, very well is develop a technology, spend all their R&D money, and they take it to the public. They do it all the time. They get beat up for being being proprietary. That is the biggest crack of crap I've ever seen. They are extremely not proprietary. They play well with everybody, especially when it comes to voice and video. It's a whole different subject. So what do you get? End result? Network fabric, any VLAN, everywhere. Stretch subnets, no spanning tree in ECMP. No spanning tree. Let me harp on that because I love this, right? This is my favorite part of this equation. So spanning tree is completely dead because you're using all layer 3 routed access, right? So how do you accomplish that, right? Basically, if you're a heavy Cisco guy and you understand Cisco, it's anycast. Every single edge switch looks the same. Show run. It absolutely looks identical. Same VLAN IP, right? Same. It's like how can these guys exist the way they do? Well, one, they use technologies like overlay underlay, so VXLAN, and 2, Lisp is a location engine inside of it, which means if a packet comes in to an edge switch, the edge switch receives that packet, right? And it understands. It first looks at its location database. Okay. Normally, in a very regular layer 2 world, I would only have one place to play this. I just broadcast it back out. All right, ARP, who is this, who is that, right? In the new world, it looks at location database, looks for registered endpoints, and says, oh, this guy, he's at a different location, he's a different switch. Let me go ahead and pass that traffic over. All right? That is the meat and potatoes of this. That is what's revolutionary about it. That is what's changing the game, in my opinion. This allows you guys, again, for complete mobility, right? Complete security, and you don't care. Same with, again, wired wireless access is treated identically the same. All right? Very important. So what I went ahead in the slide. What does that mean? Layer 3 through Layer 7 services are everywhere. They're here, they're here, they're here, they're here, right? You get ACL, security, you get QoS, you get broadcast control, and your Layer 2 is extended everywhere. And what did you do? You plugged a switch into the rack. You took 2 cables, plugged it into the core, right? Fiber cables, so if they're in a different building, whatever it is. You told DNA, find me that switch. He's ready for you. Or you could do 10 of them at once. Find me those 10 switches. All right, you found the switches, great. Upgrade them to the latest code automatically, perfect, done. Now deploy this fabric to there. That's exactly what you've done. You have not even broken out a console cable. And I am ultra critical about Cisco with that, right? We want Meraki, but we want Cisco. Like we want Catalyst, right? That's what really we want. We want the Meraki experience in Catalyst. You have the Meraki experience in Catalyst. That's why I say within the next 5 years, you will be deploying this in your architecture. It's too easy not to. You want to be lazy, right? Or you really just want to work 40-hour work week at the end of the day, right? That's like the exactly, right? Can we just work 40 hours instead of work 70 hours? I always say like IT gets the worst of it because it used to be that you're serving, let's say you're serving 1,000 customers, right? And 10 of those guys are finance, 200 of those guys are sales, and the rest of them are operations. It used to be that 9 to 5 we're all good, right? Well, then the finance guys are like, well, I want to work on Saturday. IT can you be available? No problem, I'll be available for you. And then it became operations guy, well, I want to work on Sunday. Then everybody else said, well, I want to work all different hours. And IT is the same one dude sitting there going, oh my God, now I got to cover everyone's shift. I don't have the option to not cover everyone's shift. That's why I say you just want to be lazy. You want to get to that 40-hour work week. So use cases, management, wired and wireless management. This consolidates your management if you're running wireless LAN controllers or if you're running switches, routers, things like that. Right? This now has centralized management of all that. So DNA is that centralized manager. I haven't talked about SD-WAN today. I'm not going to talk about SD-WAN today, other than SD-WAN is also managed. So Viptela's architecture, which is Cisco's new SD-WAN technology, that is managed by DNA as well. It's all policy-driven. Security and compliance. This is no doubt the biggest driver for this technology. All right, 100% our customers are going for microsegmentation like I showed you here. These two guys, same switch, same VLAN, they can't talk without traversing layer 3. These guys, different switch, same VLAN, can't talk without traversing layer 3. So security allows you to put it right in the middle all the time. You can always get in the middle. So SDA is currently not application aware, but it will be. And ACI is now moving towards application awareness. Scalability, right? Layer 2 extension, large campuses, IP address management. This is your dream for both of those.
Cool.
So where do you start? Start the timer, somebody.
Yeah, I was gonna say. So we're gonna give Jamie a break. I'm gonna get on the clock here for a second. So my goal here is to talk to you guys about how you can work this into your life cycle, right? I think Jamie hit on dead ahead. You know, we're in this world where marketing's running software-defined networking, but ultimately there's hardware behind this that makes all the magic happen under the hood, right? Everybody's hearing Lisp, VXLAN, all these different control protocols that are involved. Anybody a little intimidated on how to implement all that stuff, right? You hear about how the ZTP actually works. But in reality, to get all those different protocols to work under their hood, there needed to be investments made into the hardware and the silicon side of things. So Cisco's one of the only manufacturers nowadays who's still actually making custom ASICs. I think Mellanox is in that arena too, and obviously the scale of Mellanox versus where the scale of Cisco is, they're two different markets, right? So it's all based on what they call the UADP version 2, version 3 ASIC. It actually started in the low end of the portfolio here, and this actually didn't translate over too well. So this is the Catalyst 9000 portfolio, but it started in the 3850 family. Any users in the room been making investments into the 3800 family, 3850s? Anybody in the install base? Okay. Anybody running any Catalyst 9000s? I know there's a couple familiar faces in the room that are either seating it at the edge or the core. Okay.
Not to be confused with the Nexus 9000.
Not to be confused, yeah. So we're going to go over the 9000s
or the
to the
Catalyst
9000s.
AP 9100.
So the good thing about software-defined access is you can work in where you want to invest into your life cycle. So some of the elements that we didn't go over in the architecture is the idea of edge nodes versus border nodes and control nodes, right? So think of it as kind of where are my endpoints accessing the network and where are my decision makers being made in the network, right? Our control plane, and that kind of usually sits at our core, right?
These are fabric edge nodes down here. fabric border nodes right up here.
So in your traditional world, think of that as your access layer and your core layer, right? Pretty simple. Everybody's design networks based off of that. So if you guys are looking at a lifecycle refresh where maybe you have 2960s that are coming end of sale, end of life, look at maybe like the 9200, 9300. Your decision point there is going to be ultimately the number of virtual networks or how deep in microsegmentation you need to support, right? So maybe within your organization you define that you need to have 30 different operational units that you need to have microsegmentation. Maybe it's 3. You know, it's going to be dependent on the size and the scale of your organization. So there's a lot of planning that comes into this, as you can see, right? But also bring that planning into your lifecycle strategy, especially when it comes to how you're going to segment at the access layer. I think something that's also interesting here, and we got the nice new shiny banner here, is there has been finally a replacement announced for the 6500 series. I'm sure somebody's gone under the hood of a 6500E, non-E at some point in their IT career who's been working in networking. I found it funny that those have been around pre-Y2K. So they came out in 1999, so they've definitely lived a pretty good life cycle, right? So now we have the 9600 that's going to serve that purpose. So everything from your access to your core is Catalyst 9000. So as you guys are making future purchases for your switching as you hit the end of life cycle and refresh, I'd highly encourage that you go with the Catalyst 9000 series. One thing that will be new to you from a purchasing standpoint is all these products now have included our mandatory software. And that's all subscription based, so you have a 3-year term, 5-year term, 7-year term options. And dependent on when you're thinking, do I dive into SDA on my initial purchase? Do I wait 2 years? Do I wait 3 years? When am I going to bring the controller into play? When am I going to use ZTP? That'll be your decision point of what type of software you can get with it. So there's Network Essentials, Network Advantage, and what they also call DNA Premier. So if you want to go all in, SDA, ICE, DNA Center, you look at the top rung. Or maybe you know that you're replacing some of your access switches, and in 3 years you're going to buy the controller and you're going to implement DNA Center. Maybe you go with the Essentials and move into an upgrade path down the road, right? So it'll give you the ability to talk to DNA Center, have your adjacent applications, and also get all the inner workings under the hood to make all this happen, right? You need to make sure that the switches support VXLAN, supports VTAP, supports Lisp, and all those control protocols that come into play. So Catalyst 9000 is where you guys want to be looking as you develop a life cycle and a replacement strategy.
Yeah, and we feel like even if you're going to make a small investment in switches, let's say I'm going to buy 2, we'd like you to look at this option.
Yeah.
Even if you just, because you can't just come in and just rip it all out at the same time.
Yeah.
Right? But what you can do is you can put 2 switches in this SDA mode, right, in this SDA fabric, and treat those switches like they're legacy, right? You can put legacy VLANs on there. I can just say I want these 10 ports to be this VLAN just like I used to have it. I don't need to operate ICE. I don't need to do that. Now I can show you why I recommend it and how I can make it easy for you to consume. But if you say to me, Jamie, I want to take it simple, but I do want to take advantage of some of these features today, and I want to have at least the option, then allow us to show you that. If you're running existing 3850s, we have done conversions from 3850s into this fabric, and they've gone very smoothly. For the same principle, right? We basically said this one user had 10 3850s, and they were all stacked, and they all were built out for a specific user department. And we said, all right, why don't we just go ahead and, this is what we're waiting for. Sorry. Oh, him first? Wow. So we can take a 3850 that's currently not SDA compatible or built, and we can just run a software upgrade on it, connect it back into your cores, and then it can get the same VLAN assignment it had before. There are some limitations around it. Again, in the fabric, out of the fabric plays a big role. There are some layer 3 constraints, but again, we can walk through and explain to you how we think we should do this. So I'm ready for you guys to consume this product today. And it's absolutely the way to go if you're thinking at all 802.1x. If you're thinking 802.1x today, and you have a budget or you have a plan to replace some switches or you've got old 3850s in play, this is the best way, the easiest way to consume that model. Before I go forward, I have 2 sets of questions. I got questions for now and I got questions set up later. Anybody have questions for here that are not ACI questions? ACI is the next slide. Yep.
Compatibility with SD tags crossing your layer 3 or your routed networks where you have limited connectivity to HTTP routers or their APOS fabric.
So they can cross with things like Viptela that you put in front, but basically what they do is they encapsulate, exactly. They encapsulate and fragment the packets. So the SGTs can cross all of that, but you will have to do some, you're not going to be able to just onboard it right into a 1500 byte hard stop because all these packets are larger, right? Good question. And it doesn't have to be VIPTELUS, so to speak. It can be other encapsulation technologies. I think probably even DMVPN probably supports it at some scale. But yeah, likely SD-WAN is the way to go there. Now, there is a model where SGTs, you can deploy these guys remotely and have them all live in their own environments, and it won't cross. So there is a layer 3 model that doesn't include SD-WAN as well. It just the SGT won't carry through. However, if you offload the packet on one and onboard on the other, ICE will help identify that and still then apply the SGT on the inbound side on the other way. So there is working models for both of those. Any other questions? Now that you guys understand all about the mobility side of this, the layer 2 is dead, the ACI is going to be a breeze. So we good? Let's go. So ACI, this is for your data center people who came in here saying, I want to learn about how to secure the data center better. So ACI, again, very marketing-centric. Cisco's application-centric infrastructure allows application requirements to define the network. And this is true. This architecture simplifies, optimizes, and accelerates the entire application deployment lifecycle. The ACI fabric provides consistent low-latency forwarding across high-bandwidth links. And last but not least, this architecture operates as a single layer 3 switch. Again, that's a reference to a fabric. The whys are exactly the same. Security, performance, availability, automation, more importantly, programmability. So while SDA is API enabled and SGT enabled, it's not really designed today for your outside applications to go in there and mess things up. Where on the other side, ACI, this is designed to interop with applications regularly. In a perfect world, they would love your SQL developers to be able to develop properly to this fabric. So if they ran an automated job every night at 7 o'clock at night, to be able to push a policy during that job. Now, I don't know anyone that's actually doing that yet, because I think it's going to take a while for you to bring your developers on board. Plus, some DevOps people have to really understand how this operates. But that is what this fabric is designed for. It's designed to live, breathe, and flow with the applications. In most cases, what was his time, by the way?
409.
409 for Tim?
Yeah.
Sorry, he's got more coming. So, these are inside jokes for us. We get a kick out of them. I know you guys
You don't need to laugh. We'll laugh.
Yeah.
We'll laugh for you.
But ACI, right, it's designed to really be kind of part of the environment. It's designed to give you a peek into your network switching that you didn't have before. So these are the concepts on ACI. SGTs are still present. ACLs, TrustTech, VXLAN, EPGs. So what was an ACL is really now, or sorry, what was a scalable group is now an EPG, an endpoint group. All right? A contract, right? A contract is a little bit unique, but really it's a glorified ACL. It's a layer 7 ACL. Tenants, private networks, bridge domains, and BGP, all those do is help you bridge the layer 2 to layer 3 domains together. All right? So what does that look like? Whereas we were doing SDA with pure routed access, right? We build this spine leaf topology, so fabric border, fabric edge is now spine and leaf in the ACI world. As we build this topology, it's all the underlying core brains of this is all VXLAN at its core. All right? These guys here, these spine switches, these are your traditional backbones. Your leaf switches, these are your traditional, let's call it top of rack switches. In some cases, right? Where you deploy them and what you do with them might be different. But if you think about it, these are your backbones, your cores, top of rack. The beauty of this is, after ACI, they're all everything. The difference is, these spines only service these leafs, and these leafs service everything else, including your border nodes. So these leafs can actually take external connections right into it. So how do they actually work? I've got VTEP highlighted down there. VTEP is VXLAN Tunnel Endpoint Protocol. All right? Every one of those leaf switches, they register with these spines as a VTEP endpoint. Now they are collecting and building their own local database of who's who in the zoo. This is how they have a location awareness. So whereas SDA is designed for campus, very broad and wide, right? And it can allow for latency, right? ACI can't allow for latency. Zero, can't have anything of it. So they're using complete raw VXLAN to get that information. So we don't need Lisp, we don't need a routing protocol to do this anymore. It's VXLAN that's doing this. It's a layer 2, layer 3 protocol, kind of in one. That is a core foundational difference between ACI and SDA. The VMware integration, which is what everyone goes to, hey, this sounds great for endpoints, right? I can plug endpoints in, I can get identity. I should also say, in this guy here, one key piece is missing. There is no ICE. There's no reason to have ICE, right? You're not identifying end users anymore. You know what your applications are. You put those assignments into EPGs, into endpoint groups, right in the APIC controller. So the VMware integration, this is probably the best part of this equation, is how does ACI work with VMware? Because that's where a lot of your switching happens, right? You deploy a VDS, you've got multiple hosts, they communicate to each other, and you're saying, how in the world can I prevent that traffic or intercept that traffic in VMware? Well, here's how this works. In vSphere's VDS, right, or in Hyper-V's virtual or Microsoft's vSwitch, right, they have got PV mappings and USEG mappings, things you probably have seen before but haven't taken advantage of. You're like, why am I going to use a PV LAN? But we've all seen it in a VDS at one point, right? Essentially, you're communicating to the VDS, hey, I want you to forward all upstream traffic to me. I want to handle 100% on my territory, right? So ACI is responsible for deploying that VDS into your network, right? You basically go to ACI, right, or the APIC controller. You build yourself a virtual network, per se, and then you say, hey, I want this network, live on all these switches, and I want it to go ahead and provision a tenant network inside of vSphere. Once that tenant network is in vSphere, you take your virtual machine, right-click Edit, select your new network, and then pow, you're in business. You now have isolated EPGs. More importantly, you actually have the option to microsegment or not microsegment, right? One of the questions we had yesterday, somebody raised their hand and said, this creates a performance problem. I said yes and no, all right? Yes, I understand that you think that it creates a performance problem because you're no longer switching locally in that host, but anyone who's got a really large-scale environment probably doesn't switch locally in their host anyway. However, you have the option to deploy ACI as locally switched or not locally switched, or microsegmented or not microsegmented. You can tell ACI, hey, I want all the ACI features, all the ACI fabric, but I don't need microsegmentation in this group. You guys can talk however you want. I don't care what VMware host you're on. So you've allowed that VMware host to talk. On the flip side of it, another obvious question is, hey, NSX does this as well, and this is a competitive product, right? Is this faster or slower than NSX? Well, just like anything in VMware, any type of packet that passes and crosses, what are you hitting? You're hitting an Intel processor. That Intel processor has been designed to do a lot of things, right? But it's not an ASIC. So, I don't have an NSX, performance degree on this, but I can probably guarantee you that the latency you're going to add from doing layer 2 or layer 3 routing, layer 2 switching or layer 3 routing inside a virtual machine is going to be very similar, if not the same, as offloading that locally into a sub-millisecond fabric and getting it back. So I don't see this as a real performance impact. There might be a use case where it is, right, where VMware actually gets better performance out of that. That's where you disable that microsegmentation because you don't want it. So the next part is, well, I think VMware is in trouble, let's say, right? Or VMware is a target for a lot of people, and I think containers are coming to get them, and they're coming to get them fast, right? The cloud is eating their lunch. This is just our reality. In the networking world, if you're a network administrator, and people come into you and say, I want to go cloud, I want to go to a container architecture, I want to go to all this stuff presents a lot of problems for you today. You've got it right now buttoned up in a really nice package in VMware. What happens if we scale outside of VMware, right? Enter ACI anywhere. This is the last part of that 4 takeaways. This is the game changer for me. Since essentially you're just talking about VTEP clients, right? That's where you're at. You're talking about essentially enabling everything to be VXLAN available on the environment, in the network. Why not cloud? Why can't it also register with your ACI play? And that is today available. So ACI Anywhere is available today. AWS, Azure, Google, all those options. You can now register all of your virtual machines into the ACI fabric with the same EPGs, right? The same security policy, the same upgrade lifecycle. I think this is what really enables hybrid cloud. About 5 years ago, Cisco introduced Intercloud Fabric. They may have come and talked to you about it. That product died a very quick death. What was very exciting about it, what are you missing? Or short stick. That's going to be on the video too, by the way. It'd be great. What Intercloud was supposed to deliver for us is that one data plane across every cloud and fabric. Well, like I said, that died a slow death or a fast death, and ACI Anywhere replaced it. This is the first, I would say, legitimate play of a hybrid cloud of layer 3 across multiple clouds with that same security policy. So this now has your networking policy that exists in your data center is exactly the same as it exists in cloud. I think it's a very powerful message to people who are on the edge of cloud today. So the third point we made was ACI is available for any workload, right? And I think the fourth component of this is if you're even thinking just cloud workloads, ACI is available for that as well as software only. One thing I did not cover is, like DNA, ACI is a box or a set of boxes. In this case, it's 3. You can deploy it as a 1-node cluster, but likely it's 3. For whatever reason in their architecture, 1 is 1, 3 is redundancy, 3 is 2. All right, so there is no, can I just buy 2 of those boxes and have it redundant from A to B? There's a third node in there. It's for a witness. It's for a software function to be able to replicate these roles. But when you buy ACI and invest in ACI, you guys have a single box or 3? You have 3? So they have a 3-box cluster operating the ACI fabric. The ACI boxes in both DNA and APIC, they don't sit in the data plane. So don't worry. If they go down, it's not going to impact your stuff. You're not routing every packet into a box and out of a box. The data plane is still operational without them, right? But they are the analytics engine behind the data plane, and they obviously are the API flow, which is required should you guys actually take advantage of those great features. So if you invest in either DNA or ACI, prepare to invest in a box. In both models, they are bringing cloud services. And last but not least, virtual machines are maybe or maybe not available, I'd say, after Cisco Live. Let's wait and see. So what does this mean for ACI, right? Basically, same thing. It's the exact same graphic. Layer 3 through layer 7 services are available for everything. So every packet that enters the ACI fabric enters as a layer 2 packet, just like it would have any reason otherwise. It's now encapsulated in VXLAN, and now it's handled by a layer 3 core router or core switch, despite it being on a leaf node. So QoS, broadcast control, L2 extension everywhere, including geographic clusters. Super important for people who have multiple clusters of hosts. ACI enables this communication. And the use cases are very similar. For the management use case for ACI, you can now manage your virtual networks, your physical networks, and your cloud networks all in the same place. That's the most powerful message around ACI. Security and compliance, PCI, HIPAA, ransomware, microsegmentation, no different than SDA. You want to control your end users in microsegmentation? You should probably want to control your applications in microsegmentation as well. There is no reason for your financial application to be talking, right, to your IT administration application, right? Your ticketing system doesn't really need to talk to that. Now, your RMM tool is a different story, but your RMM tool, you might want to limit that down to just SNMP, so you limit your contract down. Scalability, again, geo-based clustering, layer 2 extension across the globe, and scale to cloud. There are other technologies involved in this that we haven't discussed, but they're there. So VXLAN sometimes pairs with OTV for you to scale globally, but within a certain reach, VXLAN is accessible and operational. Another thing that came to my mind is automation piece. So whereas DNA automates the entire fabric edge, you literally don't have to pick up a console cable. In ACI, it basically automates most of it, but primarily the VLANs, or you would think that your address segments. That's where ACI automation kicks in. All right? So where to start if you want ACI?
So it's a pretty different, actually, life cycle strategy from the Catalyst family. And what's funny is they're both 9000 series. So it all falls into the Nexus 9000 platform. Now, what makes this a little unique as compared to the Catalyst is when you go ACI, you go all in, right? And depending on the model, if you're looking for a spine or a leaf, it's hard code dictated by the serial number what type of role that can serve. Whereas within the Catalyst family, if you go 9200, 9300, you're typically serving edge or endpoints, but you can also have a 9300 serve as a control plane. So those aren't necessarily hard coded into DNA or software-defined access like they are within Nexus. So to circumvent that, what Cisco allows you to do is when you buy into buy into ACI licensing, you can run it in traditional NXOS mode. So as you're looking to replace maybe Nexus 5000s or 2000s in your environment and see 9000s in there, you can run them in your traditional high forwarding layer 2, layer 3 instance, right? Not have to dive into ACI right away. But knowing that, when you move to ACI, maybe it's a 9332, for instance, where that needs to be a spine when you spin it up into ACI. Keep that in mind for when you're planning. So that's really important when it comes to this. same type of terms and subscription arrangement that you have within DNA and software-defined access, that now you buy hardware and it's coupled with a 3-year, a 5-year, or a 7-year subscription. And depending on if it's going to be a single fabric, if it's going to be multi-cloud, if you're going to need to have assurance capabilities built into it, that's going to dictate what type of licensing tier you need to roll yourself into. So what we're seeing is a lot of our current customer base, they're seeding 9300s into their environment in NXOS mode, knowing that maybe 2 years, 3 years down, when they have enough spine and leaf adjacencies, that they're going to do a rollover into an ACI and create a fabric within their environment.
Cool. So that about does it. 1 hour, almost on the dot. Any questions? These can be ACI or SDA questions. Any questions about the entire prezo? Any questions about entry points, about conversions? Or who is running 5Ks today? Next 5Ks or next 7Ks? Any running 5Ks or 7Ks? Yes, so 5Ks, 7Ks. Yeah. So you guys are, so in your next iteration of upgrades in the 5Ks, certain 5Ks are EOL'd. I don't know about the 5548 UPs. Those aren't EOL'd yet. So you are going to replace them with ACI. So it's already on the roadmap for you. That's a natural replacement, right? If you have existing 5Ks and you want to bring in some, you guys did a greenfield, but if you want to do a brownfield, you can bring in, certain, again, spine leaf adjacencies that you've kind of built and then migrate things over. If you're running UCS today, it is really easy. Are you guys running UCS? Yes. Oh, you are running UCS, sure. If you're running UCS today, it's extraordinarily easy too, because you can update to, you can push out to multiple uplinks, right? So you can have different type of pin groups, etc. You can literally uplink to an ACI fabric and uplink to your existing fabric, and then just move the VMs over as you go. So the conversion can literally be zero downtime for you. For those who have existing 9Ks in play and want a zero downtime migration, it's a little bit different, because you can't just take those guys offline. You can't just convert their OS. You've got to build a staged fabric-based migration. So it can be a little bit of pain. But in some cases, it might be better for us to go ahead and stand up a dedicated spine leaf next to it and then move over. You guys have multiple 5Ks for 2 different purposes. So for you could actually take one 5K completely offline, replace it with a full ACI spine, migrate over, and you could do it in zero downtime. So, any questions? The ACI Anywhere piece for Azure look like? So, yeah, great question. I wish I had a better answer for you, but I don't. It's brand new, right? So I don't even know where the VTEP endpoint is, whether it's all the way on the VM layer or if it's on the virtual network layer. So the announcement's about 3 to 4 weeks old. And I imagine over Cisco Live, which Cisco Live's in 2 weeks from now, we're going to start seeing more labs available to us as partners. But for me, I want to be like the first person in that environment. I believe they actually have a model that both involves like a VPC for AWS or a virtual network for Azure, or virtual network for Azure. I think they have VTIP registration on both of those, and they also have VTIP registration from the endpoint itself. So they'll encapsulate it on the way out of the Windows platform or whatever platform you're running. So cool. Any other questions?
Yes. How big of a network environment do you think you should have when considering something like this?
So
for the small network level, layer 2 is still going to be alive for a while.
Yeah.
They can scale down this for like maybe a cloud solution or something for the small guy.
Yeah. So ACI specifically versus, so let's answer the question around ACI. If it's ACI, I think literally any workload can benefit from ACI. So if you have 3 VMware servers, probably not, right? But if you have, let's call it between 8 hosts and greater, right? I think you're a candidate. For SDA, I think it's a little bit different. If you are literally a 20-person shop, one site, I would say don't bother. You're probably fine managing one switch, good to go. You could literally build yourself port assignments in one ACL. You don't have an issue. But if you're managing, let's call it 4 to 5 different switches in different management planes and different floors or different buildings, different areas, different IDFs, SDA is a candidate for you. If microsegmentation, if PCI demands it, everyone's a candidate. I don't care if you're even on one switch. If PCI says have it, one switch might be valuable for it, especially if DNA comes out as a VM. If DNA comes out as a VM, which they're saying they're going to do it, but they're going to peel away some analytics, they're just going to keep the automation side. If DNA can be deployed as a VM, and you can collapse a fabric and a fabric border and a fabric edge together, and you can do this on one switch, I think you're going to want to do this on one switch. But the real benefit is probably not a traditional, but a core, right? Let's say you've got 2 to 3 switches as a core, and then you've got 2 to 3 other IDFs lying around, that's a perfect starting point. And you can convert IDF on IDF basis. So I wouldn't say, I guess size-wise, maybe above 50 people, right? Above 50 endpoints is probably where you want to really consider it. Definitely 802.1x. If you are invested or looking at 802.1x today, that is like an absolute go button. This is the easiest implementation of 802.1x I've ever done by a mile. And we've done a lot. This is absolutely the easiest integration and the best way to configure a switch. So, I mean, take 100 switch ports and say, apply this configuration and go. Yes, sir.
Yeah, quick one. So we have a number of Catalyst 9300s.
Okay.
At the access level. Currently, layer 2 running traditional VLANs.
You're this guy.
Yep, that's us. So,
That guy.
yep. So my question is, what is the, I guess, level of effort and potential downtime
For the client.
when we get the DNA controller in and we start pushing out
Go to town. What's your core right now?
our cores ACI?
Not on data center.
Your campus.
Campus. What's doing your layer 3 routing?
Yeah.
Every campus has got its own unique. But do you have like a 9300 stack doing the core?
I have an MPLS circuit pretty much at every site with a router and then a layer 2 switch.
Oh, so the router's your core. The router's doing your layer 3 at every location. All right, so this is going to move into it. So the answer is there's not a lot of downtime. As long as it takes for you literally to, depending on 9300, so these guys are running probably 16, what are they running, 16.9 code? Probably 16.9 or 16.10, one of the two. Oh, 16.6, okay. So if you push those out, you push that out early, but even the 16.6 has the plug-and-play agent on it. There's a PNP agent, by the way. It's kind of really funny. It has a PNP agent on it. As long as it takes for the upgrade and you to reapply the policy, is as long as it takes. I would tell you somewhere between 35 to 40 minutes per switch. That's the downtime. The caveat is, remember I said about layer 3 being in the fabric or out of the fabric? You're either all in or all out. You can't span that layer 3 network across, right? A 9300 in layer 2 mode, right? Traditional layer 2 mode, and the 9300. So a lot of our customers that are looking at this implementation are taking advantage of doing re-IP scenarios, right? Where they're saying, all right, I don't really care about that anymore. Let me go ahead and re-IP that, right? In some cases. But then if you got printers, listen, it's end user stuff. You got printers, you got other access stuff that gives you headaches. You gotta have a plan for that. So if you have a very large campus and you've got 20 switches in the campus and you're all layer 2 across the board, then I can see a little pain there. But if you have any layer 3 segments or any routed access at all that's currently there, no pain. It's very flawless. We took 3850s from this customer. This is how good it went with this other customer. The lazy customer, this is how good it went. And I kid you not. We did all this in a lab first. So we had existing 9500s, so his core, his fabric border set up. And we said, all right, let's see how a 3850 actually works in this. And we had never done a 3850 in this fabric before. Took his 3850. He was able to take one out of production because he had extra capacity. Went ahead and swung it in. We upgraded it from whatever was running old 3.3 code to the new generation iOS XE plus 16. It was 16.9, I think, for him, right? Once we got it up and active, and it took a little bit to actually automate the upload of code, et cetera. Once we got it up and active into the fabric and tested it successfully, he's like, all right, so when can we do production? And I said to him, I'm like, when do you want to do production? He's like, well, why don't we do it today at 5 o'clock? So we did the first site at 5 o'clock. We just went ahead and took an existing switch stack. He had 3, so his sites are all fiber connected. It's a very large campus, but he had a switch stack of 3. At 5 o'clock, he's like, all right, everyone, network maintenance, here it comes, and boom, we just literally went over there, took a USB stick, upgraded the code through USB, and then PNP agent did the rest. After we did one site, we woke up the next morning. This was a Pi project. It was your project, right? Woke up the next morning. Everything's great. Everything's running. All right, what do you want to do the next site? Let's do it tonight, 5 o'clock. Okay, no problem. We did the next site at 5 o'clock. We had 4 more sites remaining. When do you want to do the next site? Oh, we did it. We're good. Right? When do you want to do the next site? We did it. We're good. Customer started doing his own sites. And he was doing them in 35 minutes of downtime. The only thing that him and I had odds at that it took me a little while, but I convinced him was, let's use ICE for everything. Let's not static the old as it was the new. In other words, let's not just take a brand new upgraded SDA switch and go back and physically hard code a bunch of VLANs onto it, like printers and stuff. Let's use ICE to do that. So then we started using ICE to do that in the future rollouts, and we basically started taking ICE assignments, saying location awareness, right? This switch is in this building. Okay, so if this switch is in this building, let's first see if the client's 802.1x are compatible. If they're compatible, let them authenticate. If they're not compatible, default them back to their previous VLAN assignments. I say VLAN assignments, but their previous address space. So, so I would tell you, man, we walked in thinking this was going to be the most painful thing we've ever done, retrofitting and brownfielding this, and we walked out thinking, let's do a lunch and learn on it. I mean, it's exactly where we came at. So I would say I'm not that worried as long as your end users can survive a little downtime. Wireless, entering wireless, a little bit different, right? So this customer also had wireless. That's not really impactful in 3850s, but if you're converting wireless over at the same time, it's a little bit different. The planning is key. So if we sit and plan it, and then we can afford to do it. We do one department maybe or something like that. Then I think after that you'll say, we can blow this all in a weekend. I mean, it's really that good. It's really that good. So the automation, I mean, automating the configuration of these switches and not having to think about it and then doing a show run on it and go, wow, I would actually have done it like that if it was me. In fact, it's doing things that I don't even think about. That is a moment. The automation is so good that when you start planning it, you say, this is specific to SDA, it says, give me a /16 for all of your layer 3 adjacencies, right? I want a /16, and you give it. You say, okay, take 10.0.0.0.0 /16. You do whatever you want with it. In this world here, if you previously in layer 3 routed access, you have this massive spreadsheet with these port assignments. Oh, this port's connected to this port, and here's the /30 here. This port's connected to this port, here's the /30 there. It would give you a headache, right? You don't care about that anymore. DNA automates all of that for you. It segments all your all your /16. It cuts it into, might even cut into /31s actually, all the way down the board. Boom, boom, boom. New switch, new IP assignment. Do you care about the IP link anymore? You don't, because DNA lets you know if there's a problem with it. It tells you exactly which link, which port, all that stuff. So it's done a killer job of abstracting all the headache that used to drive you crazy with a huge Excel spreadsheet, all these subnets, all that stuff. It's gone. You know, you can do an entire implementation with like 5 address spaces. You know, 5 big /16s. You just don't care. And I think we're finally in our lives as administrators where we're okay with that. You know, we used to say, oh no, I want to control everything, and now your plate's so full and you've got so much to deliver on. You're saying, I will let a system manage that IP for me, and I'm okay with that. I don't have to know what the IP of that device is. You know, I don't have to know what all this stuff is because DNA handles it for you. I think we've all been in the business a while and know that feeling of saying I want control versus letting a system handle it. And this is the first system I would say, let it handle it.